In the world of quantum, uncertainty is not at all a limit. Rather, it is a gateway towards innovation. With this, I am Sreem Satpathy from OAB presenting an interesting learning seminar topic of quantum age, its potentials and its challenges. So, before we move on to our main topic, we will see a brief classification done by English physicist Paul Davies. He classified 19th century as mechanical age, 20th century as information age or IT age, and 21st century as quantum age. Now, the question arises, what is quantum? So basically, quantum is the smallest bit of anything like photons, atoms, the subatomic particles like electrons, neutrons, etc. This term quantum was first time defined by Max Planck in 1900. So to understand this in a better way, we need to see some differences between classical physics and quantum physics. So firstly, our classical physics is deterministic. It means it is predictable. If we take a ball and leave it from a certain height, then we can predict that at what velocity it will hit the earth. But in terms of quantum physics, it is completely probabilistic. For example, if we take example of a photon of a light, then we can't predict that at which point of time a particular photon will be released from the smart body. Secondly, there is clear separation in matter in classical physics. The particles behave like particles and the waves behave like waves. But in quantum physics, this changes completely. They have dual property. It means energy or matter can behave both as wave and particle. This is also known as wave-particle duality. Then we have to know what is quantum age. So quantum age is the current technological era which is driven by quantum mechanics. In current quantum age, quantum computers are used, which have QPU as their processing units, which means quantum processing units, which are based on qubits. Now let us jump into some potentials of quantum era. So firstly, it provides us super fast computing. It means its speed is much more than a classical computer. This is because they use qubits and which are based on superposition, which means here you can see that normal bits have either 1 or 0, but these can work simultaneously on multiple probabilities and the speed is increased. Additionally, it also provides complex problem solving mechanics which classical computers do not do. Thirdly, it also provides us security in communication. The quantum cryptography is much more better than a classical cryptography. Then the enhanced level AI and machine learning provided by quantum mechanics which have much more generation capacity than classical AIs. And the current robotics is also based on quantum mechanics. And then it also helps us in faster drug discovery. This is because as it is the study of nanoparticles, and it also results in faster drug discovery. And the MRIs are also based on quantum mechanics. But just like anything in universe, they also have some challenges in them. And firstly, it is extremely high cost. This is because they need to be stored in 0 degree Kelvin, which means minus 273 degrees Celsius, which require very high cost infrastructure. Secondly, the complexity of knowledge in quantum mechanics makes it even harder for experts to solve quantum problems. Even great scientists have to more than 200 years just to learn its basics, and we are still learning from the quantum mechanics. Thirdly, there is a digital security gap while transitioning from classical mechanics to quantum mechanics. Suppose an important data is stored in classical encryption method, and this is a quantum computer. Then this is much capacity to take the data and leak it, which may harm nations and institutions. Then it may create social disruptions like losses of jobs, degradation of social values, etc. And lastly, there is a technology gap between economically developed nations and those nations which are not developed. For example, Nigeria is a nation which is not that much developed economically, but Japan is leading producer of quantum mechanics, and which countries may lag behind. But everything in the universe has some potential and have some challenges. But the point is that how we manage them. If we manage them in a good way, if we are able to turn the challenges into its potentials, then it will always favor the human beings. But if we manage in a warfare and if we manage them in a bad way, then it will act as a disadvantage to us. And if it is managed in a good way, then it will transform the whole complete science, technology, and society. As we are living in the modern quantum way, we have to be aware of the new technologies which are emerging around us. And the government also feels that importance. Hence, the government of India has introduced National Quantum Mission in 2023, proposing research and development till 2031. At last, I would like to conclude my seminar by saying a beautiful quotation that even the tiniest particles holds the biggest possibilities, and that is the promise of quantum age. That's all.